So hello everyone, welcome to happymath.com. So this time we keep discussing about the sampling mean distribution and central limit theorem. So through the last video we construct the original histogram here, and then when n equal 2, so I'm gonna name that so you can see a little better. So when we do every two sampling distribution, the histogram we got like this. So this time we start covering n equal 3, 4, and 5. Okay. So now n equal so I'm gonna moving this down here so that I have enough space. Okay, now n equal 3. So which means we are selecting any random 3 data here. 3 data. Okay, so open the parentheses and I just go to fixing this value. Oops. And also fixing second value as well. And then plus third data here and divide by 3 this time because we are doing sampling mean. So remember, you need to select any 3 data and then divide by 3 basically. Okay. Then now, so I do 5 and 6. Okay. Then now next one is from the second data. I'm gonna fix. Then plus third data. Plus 4 data and divide by 3, and now I can do one more. Okay, then the last one is this plus this plus this. Okay, and then divide by 3 here. Okay, so that's basically when n equals 3, our sampling mean distribution data here. So based on that, I'm going to also create the frequency table and the histogram. So histogram, and then input data this time it will be this one, and then so bin range still upper limit here. Okay, then output range I'm gonna maybe switch around here this time and chart output. Okay, then now okay. Then now we have this data. So I'm gonna name them n equal 3 here. Alright. Then I'm gonna leave it like that. So I'm gonna moving this down to maybe next to n equal 3. And then also I'm gonna delete this more part so we only see the data part here. Okay, then now n equal to 4. Then now you understand what I'm gonna do. It will be every 4 data and then finding the mean here. So equal to 1. So plus second plus third plus fourth and divide by 4. Then we can do one more. Okay, then next part here. So we can do 1. No, sorry, I didn't put that equal sign. So equal sign. So 1, 2, 3, 4, and divide by 4 here. Okay. Then now, this time because we the popular data is only 5, so we have only 3 data set here. Okay. Then based on that, I'm gonna draw the histogram based on this data. Okay. Then now input range, switch this one. Bin range still our upper limit. Okay, this time I'm gonna display maybe around here. Okay, chart output, that's good. Okay. Alright, then I'm gonna have this one here, so I'm gonna put n equal to 4. Okay, now I will put so n equal 3 and then n equal 4 maybe next below n equal 3 here, so we can compare. Okay, now the n equal 5, then there's only one case here because now we already reached out to maximum population basically, because we only determine n equal to 5 here. So now I can make 1 2 3 4 5 and divide by 5. Okay, then now we have only one blank here. Then let's see what happened if I do this one. So go to data and data analysis and histogram. Now I'm gonna input data set become only this one. Okay, then now I'm gonna bin range is same, so maybe input around maybe here. So, okay, now it shows that bin range cannot be empty like that, right? Okay, the reason is, so do you know why it happening here? Because we already reached to the maximum data here. So sampling mean distribution means, we cannot actually make all the population data and divide by number of data. And it is very obvious because we have only one bar and then one frequency value. That's the reason. Okay, then now in this scenario we can only compare the original n equals 2, n equals 3. Maybe I can move n equals 3 up here so we can see better, and then n equals 4 here. Okay, so whenever we compare this 4 data here, see the original was basically the range was between 51 through 79 here, and then n equals 2. Now this upper limit suddenly little bit moving toward that center line here, and the 51 is really small, and then now it looks like a normal shape here, a little bit normal shape here. Now n equal 3 is a little bit more symmetric. Okay, and then now we can also see now all the data sets start gathering to the center area here basically, right? And now n equal to 4, now this part totally disappear, and then now we have only these 2 bar. But eventually, if it was a little bit bigger population size, then we eventually will have only one case anyway. That's what happening here. Okay, so I'm gonna show there some examples. So give me a second. So this time I organized 10 data here. So before it was 5, now it's 10, so it's kind of double, right? So this is my original graph here. So this one. And then now I do all n equal 2 to 9 distribution, and then now those are histogram here. So original n equals 2, n equals 3, n equals 4, 5, and 6, 7, 8, and 9 here. Okay, then now compared to the population data only was 5, so because it's 10, so we can see a little bit more central limit theorem of this data here. Okay, then let me clear what is going on comparing minimum value and the maximum value here. So the yellow highlight number is minimum value. So before 48, now n equals 3, I mean the original was 40 here, but now we do n equals 2, 48, 352, 4, 55.25, and n equals 5, 59, 6, 60.1667, n equals 7, 65.23, n equals 8, 68.62, n equals 9, 71 point something. Okay, so those minimum value keep increasing toward the center value here, right? And now what about the maximum here? So before the original was 94, but now n equals 2 was 93, n equals 3, 92.67, n equals 4, 90.5, n equals 5, 88, n equals 6, 85.67, n equals 7, 82.71, n equals 8, 75.38, n equals 9, 71.44, like that. Okay, so which means So whenever the sampling mean distribution is increasing more and more, then data gathering center more and more basically. So that's basically central limit theorem. So again, sampling distribution means we are finding number of n. So it can be n equals 2 or n equals 3. So it is determined whatever you feel like. Anyway, every 2 data or every 3 data, and you are finding the mean value here. And then now the central limit theorem means whenever it approaches to the population data, then obviously all the data gathering to the center, and eventually we will have only one bar. So that's the central limit theorem. I hope this video helped you. So we did two different parts here, part 1 and part 2. Please watch both video, and then I hope this concept is clear to you this time. Alright, thank you for joining, and then I will see you next time. Bye.